Hello and welcome along to my introduction to the 5 or 6 big ideas for teaching for mastery. I've been teaching for mastery for the last 3 years, and or at least I started 3 years ago. I'm still learning. I think it's a long process to get your head around transforming the way that we teach maths for the better. But this is my take on each of the 5 big ideas to start to give you something to think about. So let's have a little look. What is teaching for mastery? Lots of you will have heard about teaching for mastery, but won't necessarily know for sure what that means. And it's really a deeper, more embedded way of learning maths, or any topic really, but it's about small steps, taking small steps to learn new ideas, new skills, but whilst also thinking about how they fit in to everything else we already know in maths, so that the whole of it is connected, and so that we can build fluency throughout the curriculum. To give students and teachers actually more confidence in their arithmetic and their ability to calculate quickly and efficiently with numbers, and then to move on to algebra. Obviously, we want it to be sustainable. We want it to be that students understand maths and retain that information so that it can be sustained and built upon, so that we can connect to all the other areas of maths. The essence of mastery, this is a document I've taken from the NCETM, just because I think it's so valuable in terms of the ideas that are here. The belief is that all pupils can succeed. I've popped most on there because I've certainly had students in my classroom, just literally I'm talking perhaps 1% of students who, you know, even though I've tried lots of wonderful ideas and ways of teaching, and I can actually engage them and get them involved and get them thinking mathematically, for some reason, just with a very, very small percentage of students, I am struggling to get that to be sustainable. And it might just be that that's something I need to continue working on, but time will tell. It's about whole class interactive teaching. So there's no lecturing. It's more for me about facilitating rather than teaching, where students can work together. Everybody works on the same small step, although some of them will go in a little bit deeper than others, depending on how rapidly they grasp the main concept. But even so, we don't move them onto a new concept. We keep them on that concept and provide opportunities for them to examine it from all sides, really, so they can really understand how it fits together with everything else. It's ideal if pupils can master each concept before they move on to the next part, because we don't want any pupils to get left behind. For me, I see it more as a lifting all students at the same time, rather than pulling up the best ones from the top, creating more of a pyramid. This is far more of a sort of a flat, bringing everybody up at the same time. So for that, we do need to intervene with those students who are struggling to keep up. They may need a little bit of extra time, a bit of an extra explanation. I know in primary sometimes they are holding students out of assembly to be able to work with them on a small group or a one-to-one. And at secondary it might be that we can use form time, or even just within the lesson, just making sure that we provide that little bit of extra support to those students. I've already mentioned small steps, and I think this is a big thing. Each lesson only teaches one small step of maths, only works on one small step. But within that step, taking it to every possible circumstance, if you like, in which they're going to meet that. A typical lesson might include some questioning, short tasks, explanation, and really that for me is explanation from one student to another, rather than just the teacher standing at the front, although obviously the teacher's there to consolidate and to make sure that we're all identifying the most efficient way forward. Obviously there'll be some demonstration and plenty of discussion to really get students knowing with what they're doing. Okay, so there's procedural and conceptual understanding. And we can develop those together through very careful planning of exercises using something called variation, which you may or may not have heard of. For me, I do think of it as intelligent practice. So students get to practice this new skill, this small step that we have enabled them to learn, that they've discussed. But the practice isn't random. It's very focused in terms of getting them to really think about certain aspects of it to develop their understanding while they're practicing. So intelligent practice. Lots of time. For me, it really is a slowing down of what we teach. But the depth with that, the going in much deeper, actually has far more benefit than sort of just skimming the surface and dashing through lots and lots of topics in a short space of time. We provide the underlying structure to the students, so they're able to see how everything connects together in maths, so that they can really build their understanding across different areas of the curriculum that actually, even before I started Teaching for Mastery, I hadn't always realised were connected. These things are becoming more and more clear the further I go, and I'm sure I've still got plenty to learn on that. There is a necessity for key facts to be learned, so that students don't have to be continually stopping and thinking back through their arithmetic. But you know, I think the way that we teach in Teaching for Mastery develops that too. So really supporting the students to get that sort of embedded learning. Okay, so what is mastery? Mastery. This is a question we discuss quite a lot within Teaching for Mastery. Is it just good teaching? And there are certainly huge areas of crossover between those two things, between Teaching for Mastery and good teaching. There are many elements that would very much fit both, but Teaching for Mastery is something more again, because it's a bigger picture. So even where before I would certainly have had certain topics that I would say, looking back now, you know, fit very much into the Teaching for Mastery themes and ideas. Actually, it is more about the connection and the interconnection between all the different topics. So although I would hope to, you know, class myself as a good teacher, my teaching has definitely improved across everything now that I'm Teaching for Mastery. So it is different from how we have traditionally been teaching in secondary schools. There's a real move away from teaching procedures to teaching for understanding. Often I refer to Teaching for Mastery as teaching for understanding, because I think that's where the crux of it really is. Okay, so there are 5 big ideas of Teaching for Mastery, which are on this diagram. You can see the 4 around the circle, the 4 quadrants of the circle. We have representation and structure, which is a lot about using manipulatives and representations and diagrams to really embed the understanding. Mathematical thinking, just getting the students really thinking about the maths, not just sitting, watching, listening, copying, you know, repeating what we're doing, but actually thinking about the maths, trying to develop their own understanding and each other's through discussion work. There's variation, which is what we were just talking about with intelligent practice. I'll go into that more in a moment. And fluency, which for me is a much bigger idea than the other 3, in terms of it's difficult to plan for fluency within a single lesson. Fluency is something that the whole of Teaching for Mastery builds up over time. So that students are able to really see how their skills fit in with the number system, and therefore can become much more embedded for them than just a string of facts for them to learn. And then there's coherence, that small circle at the side, which literally runs through everything that we do. It's how the whole bigger picture fits together. And again, that might not always be as obvious. You might not plan for that in every lesson, because it is about a sort of a more macro idea, a bigger idea. But certainly there will be elements of every lesson and across the scheme of work of the coherence of how all of maths fits together. And you'll notice that we've got making connections in all the corners of that, and also that we're mentioning about small steps, just moving on in small steps. So I'm going to have a look at each of those 5 big ideas just in a little bit more detail, so you can really have an idea of what we're doing in the classroom. So here, the first big idea, representation and structure. For me, you can really plan for opportunities for representation and structure in most lessons. It's about that concrete understanding of what we're doing. With Dean's blocks, you can see a diagram of Dean's blocks on the screen. Dean's blocks, which when we think about teaching column addition and subtraction, students sometimes, they have no idea really what it is that they're actually doing. They've just learned the procedure and they're not quite sure. So if two numbers, for example, add to 12 in the units column, occasionally a student will say, well, which one do I put into the next column? Is it the 1 or the 2? This concept can be thoroughly understood if we use Dean's blocks to help explain it and really embed that idea of exchanging the tens and putting that tens into the tens column or into the next column. I think it's really powerful in terms of eliminating those misconceptions. Numicon, which you can see on screen, I've got a set of Numicon. I found them to be so valuable in terms of just getting students to have a basic understanding of odd and even numbers. I think students think that odd numbers are linked to 1s and 3s and 5s and 7s and 9s because of what we talk about with that's what's in the units column. But actually, all odd numbers are a pair of numbers plus 1. They're all 2s plus that odd 1. And I think that concept is quite key to them understanding all sorts of things about numbers in terms of how they multiply, subtract, divide, add. All of those things can be better understood when odds and evens are better understood. I've even used Numicon to introduce the concept of 2n and 2n plus 1 whilst teaching proof to year 11s. I just think that they're so good at representing the way all numbers are. I've even used yogurt pots in the classroom to represent an unknown variable. Just drop a few counters inside so they can't see how many counters, but we can call that X, and then we can add to it, subtract to it. We can have 2 or 3 pots, and it really helps to understand the idea of a letter representing a number that we don't yet know, but that we can still work with. I just think it's really powerful for the students. Also on here, I've got a diagram of some algebra tiles. These can be so lovely for teaching some of these really abstract concepts that we have in algebra, linking it back to area, linking it back to number and what we do with number, just developing it that little bit further in terms of their understanding, so that eventually they can stop using them and they can see how to do this. They can recognise what it is that we are doing without using them. But just initially, just gives them that extra level of support that I think can be really quite powerful. And the difference of 2 squares, completing the square is wonderful. When you teach completing the square with algebra tiles, you'll never go back. It's a great way of really getting that understanding. Okay, the next big idea I wanted to have a look at is coherence, which, as I said at the start, it's really difficult to plan for coherence in a single lesson. But it is about working through a well thought out curriculum, a well thought out scheme of work, just teaching one simple idea at a time, but allowing students to examine that concept from all sides, if you like, to be able to complete it forwards, backwards, to test the limits of it, to make sure they really understood, well, I can use it here, but I can't use it there, to really examine it, to examine the impact of that by through tasks of variation, that sort of thing. And to allow them that time to really think about, this is similar to something we do in this other area of maths, to really link all those different ideas together. The coherence, sometimes when a student says something back to you, or recognises a link with another area of maths that even you've not thought of, it's so powerful. and really can, you know, help you to understand the maths better. Coherence is wonderful. I absolutely love this area, even though, like I say, it's just that little bit more abstract in terms of teaching each lesson or planning each lesson. Okay, fluency. So fluency is not about students learning their times tables and therefore being able to use their times tables when they do every other topic. It's about them understanding our number system and understanding how numbers behave, recognising all the arithmetic laws, being able to apply them, associativity, commutativity, distributivity, and using those to find the most efficient way of carrying out a certain question. And really we need to explicitly teach that to students. I think too often over the years we have allowed it to be that students who make excellent connections for themselves and recognise little tricks to do things, we just let them have it, and let other students perhaps carry on and struggle a little bit because they just, you know, don't know those tricks. Whereas, you know, for me, I think we need to actually start to really teach those skills and those things that we think of as tricks, but teach them and recognise that they form a very valuable part of our maths, and to really allow all students access to those efficient ways and methods of doing calculations in their heads, as far as possible, so that they're not having to really think about those things when they're in the midst of a 6-mark GCSE question. They don't have to stop and think, how do I do that? They just already have those skills, freeing up their minds to really focus on unpicking a problem. So yeah, there's an awful lot we can do on fluency, but for me it's about really going back to basics, really thinking about the arithmetic laws and how we can apply them, how we can split numbers down and move them around in a way that suits us to make our mental calculations more efficient and easier to make. Okay, mathematical thinking, and I really do think you can plan for mathematical thinking in all your lessons, because mathematical thinking in most cases for students is going to involve mathematical talking. It's going to involve them talking through a problem with one of their partners. It's going to involve them explaining things to each other, arguing with each other to a certain extent, really testing each other's understanding, using lots of skills from an oracy toolkit that we had many years ago at school from the literacy department. That's actually really helped for us. We use lots of those oracy tools within the classroom, within the maths classroom, and they can be think, pair, share, which it can be a wonderful tool to really get them talking to each other once they've had time to think for themselves. Pose, pause, pounce, bounce, it's another great one, just to get, you know, once you've asked a question and somebody's answered, rather than immediately, you know, getting involved and correcting or congratulating the person on what they thought, letting other students reflect on what they've said and seeing if they've got something to either contribute or to question about that answer can really develop all of their skills in terms of what they are thinking. I like to use convince me and prove it, and all these little expressions, yes or no, because there's an awful lot out there that we can use to really get them thinking. I also like true false exercises in terms of getting them thinking, because if we really test their understanding of a concept that we've taught them, we really need them to think about the boundaries of where it's possible, and true false can really get them thinking about that and really checking whether or not it works in every situation. There's an awful lot we can do on that, and that is something that I'd started before I came onto the Teaching for Mastery programme, but actually it's fitted in so beautifully that I'm now keen to share my oracy toolkit that we've used at my school with other people in maths, because I think it really helps to develop that mathematical thinking. If we don't get students reasoning out loud, putting their own reasons, their own mathematical explanations into words, we can't really expect them to be able to do that in writing when they get into their exam and they're asked to explain their thinking or to give the reasons. If they're not able to think it out loud, you know, they're going to struggle to make that additional step. So I do think we need to really develop that in the maths classroom. Okay, so variation, which I mean, it's such a rich area for developing our maths teaching that now if I you know, go to teach a topic I haven't taught for a long while and I haven't yet changed it or adapted it since teaching for mastery, I look at some of the exercises that I used to give, and you know, literally it's head in hands. I can't believe I ever thought that that was going to be valuable to the students in any way. You can see I've put a few examples of things on the board, but for me, variation can be, well, it falls for me into two distinct areas. There's using variation, using clever questioning initially to actually get students to understand a new concept. So the two blue ones on the screen you can see for that, and then there's, you know, once they've actually had a go, seeing if they can apply that into a number of different circumstances. So the 10 to the power of 0, 1, 2, 3, 4, 5, 6 and down into the negative powers. That's an activity I would use at the very beginning of a lesson on standard form. And I use something similar when I'm teaching laws of indices. And I recommend that they start with perhaps 10 squared and then do 10 cubed and move up from there, and then get them to start moving down. And really try and get them to notice certain things. You know, perhaps, you know, the negative powers produce smaller numbers. We're dividing by 10 as we move down, so it sort of gives us an idea of where we can go. And just try and really get that understanding before we then start to teach the really quite abstract concept of using negative powers to represent very small decimal numbers. The same with teaching adding and subtracting negatives. I often get them to use that pattern. So I'm keeping the 4 the same, I'm changing the number that I'm adding by 1 each time, and therefore when we get down to 4 plus negative 1, it makes sense that the answer is 3, even if we don't know that the answer is 3. We can see that we are adding a number that's 1 smaller, so the answer will be 1 smaller, and it really draws out some wonderful discussion work that students can think about. Obviously, we would also mention, you know, commutativity and thinking about it being -1 plus 4. But I think, at, you know, very beginning to try and introduce that concept of adding negative numbers. It's a really lovely way of students starting with something they know and able to make those sort of connections for themselves so that they can see what makes sense. These questions at the side on the difference of 2 squares, by keeping certain aspect the same, so on questions 1 to 6, they're all very similar, but it just starts to get them to think about what they're looking for with the difference of 2 squares. And then as we move on to 7 to 12, we're really going deeply into the concept there of looking for things that are squared and noticing that they are squared things, if we can say that. Even when it gets to y to the power of 4, that's still something that has been squared, and x plus 1 squared. Those things, it's really stretching their understanding of the difference of 2 squares. But hopefully by keeping one thing the same, so by keeping it as take 49 at the end of each of those, we're able to free up part of their brain to really focus on, okay, so what am I doing with this term that's at the beginning? What can I do? And I just think it just can help to really extend their understanding, rather than just giving them a variety of mixed up square things. I just think it can really help to develop their understanding. Okay, so let's have a look what's next. The central idea of of teaching with variation is really to keep certain things the same and to change other aspects. You know, we can do this even with shape. You can vary, so you've got the triangles written in or drawn in other orientations to really extend their understanding of the sloped side. You know, the students call it the sloped side a lot. Well, you can see here in the third triangle, it's actually the two smaller sides that are attached to the right angled triangle, right angle, that are sloped. So, you know, it can really help to understand that actually the longest side, we can either call it the longest side, or we can recognise that it's the side opposite to the right angle or the hypotenuse, and it just can start to really develop that idea. So we move away from just calling it the sloped side to being more technical and more mathematically correct, if you like. So when I'm planning any new topic, this is really where I start while I'm thinking about it. Once I've decided on my small steps, and once I've decided, you know, the order in which I'm going to teach things, this is the next thing I start to think about. Okay, so in terms of variation, what's my standard sort of question? Where am I going to start from? What are the sorts of things I might get them to start having a go at? But also, what's my non-standard? The thing about non-standard is that the new GCSE uses an awful lot of non-standard questions. There was a multiple choice question on one of the papers either last year or the year before, asking students to convert a percentage to a decimal, which is fine, but the percentage they were asked to convert was 0.07, I think it was, percent. So a lot of the students were flummoxed actually by the 0.07%, changing it to a decimal. And I think, well, perhaps that's something that we've never taught them. Perhaps that's, you know, our fault, because we've not provided them with those opportunities to really have a go at their skills in non-standard situations. So, yeah, this is a good starting point for planning any lesson for me. So start with the standard, then think about your non-standard. And the non-standard, you can go in a number of different directions, not just into decimals and fractions and negatives, but sometimes into algebra, just really thinking about what else could we have here. And then negative variation, what is it not? What are we not asking them? I often use true, false for that. So this looks very similar to this skill that we've learned, but does it still fit? Is it still a part of this? So there, you know, there's definitely an element in your planning of thinking about what it is not. Okay, so we come on to my last page of my introduction to teaching for mastery, and that is my concept of the sixth big idea, which for me is this rigour. And I hadn't really considered this at all until I went out to Shanghai to see the masters, if you like, of teaching for mastery. When it became so clear so quickly throughout the secondary and the primary schools that in Shanghai they use algebra as it should be used, as it was originally meant to be used. It is the language of mathematics. It's not suddenly introduced later as a topic as such. As each concept is taught, right from commutativity, you know, lower down in the school, they would generalise that rule, A plus B is equal to B plus A, and it just gives those the students a very gentle introduction to algebra as a way of writing out what we know about maths in very general terms. There's certainly an element of them proving each rule as they go, and I saw that to be very powerful, and that's certainly something we're going to be doing at my school going forward, starting to think about how we can introduce a gentle version of proof right from year 7, really getting them to think about an odd plus an odd is even, and that sort of thing, and you know, using numicons, using that sort of thing to just get them to start thinking about that rigorous side of mathematics, which actually for me makes it more powerful. And also using formal notation. I saw a primary class, grade 4 primary class, on a lesson where they were looking at parallelograms, and they were using formal notation to define what they'd what they'd learned. Angle ABC is equal to angle ADC, and actually it was wonderful. It was a real eye-opener, because if we don't teach those things, if we don't generalise it early enough, then the students see it as a big sudden change, and why are we doing this now? But if we use it like that from the outset, then students just adapt very naturally to the idea of using that formal notation, which really helps to develop their understanding. So for me, this is me, I'm lobbying everybody I speak to about introducing the 6th big idea. I'll let you know how I get on with that. But in the meantime, if this is something that you might be interested in starting to work on teaching for mastery at your school, there's a couple of things that you can get involved with the MathsHUBS. So you can train to be a mastery specialist, which is what I've done. So I'm just finishing my 3rd year on this. I've been working with other schools, and the recruitment for that is actually going on at the moment. I think the closing date is the 26th of April, so do let Jo know if that's something you're interested in, so she can let you have the application and information pack to get involved in the secondary mastery specialist programme. It's 15 days per year across those 3 years. So, you know, you would need to make sure that your school are happy for you to be out for that time. All the supply cover is paid, so the school won't miss out. And obviously the course itself is fully funded by the NCETM, so you don't need to worry about the cost. If that does feel perhaps a little bit too much for some people, you can get a couple of people from your school onto the Teaching for Mastery work group, which we're running. That would be working with somebody who has finished that 2-year mastery specialist programme and are into their 3rd year and working with other schools. So that's a programme for 1 year, and the school still receives money for supply for 10 days for those 2 staff, and obviously again is fully funded in terms of there's no cost for the CPD, and it will just give you an opportunity to start to really explore teaching for mastery within your own classroom, and then gradually moving to the wider concept of working with your own department. Again, anything that you're interested in with that, do let Jo know, and she can send you all the information and details. So that's it. I hope you've enjoyed it, and I hope we've given you a flavour of what Teaching for Mastery is and piqued your interest so that you join us on the course. Thank you very much.